So for number 20, I'm given a triangle again, kind of like I did in 19, but it gives me a little bit different information here. It gives me the top angle this time and not one of the base angles. So going back to that base angles theorem, kind of the converse of it almost, is that when I have two side lengths that are the same measure, the angles directly across from those side lengths, basically the angle that opens up to that side. So if you can think about this angle opening up to this side here, and then on the other hand, this angle opens up to this side. Okay, so think about angles opening up to be sides, or you can think of as being directly across from them. Okay, so when you have two side lengths that are the same measure, you can say that the angles directly across from them are the same as well. So it's not giving me x here though, it's giving me 30. Well, I need to think, how many total degrees are there in a triangle? (180). So if you didn't already know that, 180 degrees is the total number of degrees in a triangle. So if I know that this and this are the same measure, I could do one of two things. I could set up a little equation saying, okay, well, if that is x, this is also x, because those have to be the same. I can say 30 plus x has to be 180. It just has to be. Well, x plus x is 2x. So 30 plus 2x equals 180. When I subtract 30, I get 2x equals 150. And then when I divide 150 by 2, I get 75. So I know that x has to be 75 degrees. Now, that was a little equation I set up. You don't have to do that every time. In your head, if you just want to think about it like this, well, if the total degrees of my triangle is 180, I know that 180 minus 30 has to be these two right here. So 180 minus 30 gives me 150. So those two added together has to be 150. And if I know they're the same measure, I can just divide that number by 2 to get my x value. Now, that's the exact same thing I did over on the right in the green. I did a little more in my head. So yeah, x has to be 75 degrees there.